next speaker, presenter is Mr. Frank Busick. He is a geospatial applications engineer and consultant with nearly 20 years of experience in remote sensing and GIS. Holding a master's degree in geology from Bowling Green State University, Frank has worked for and or with federal, state, and local governments, as well as private sector software vendors, and owning his own geospatial services business. Feature extraction and image classification has been a main focus of activities over the last 13 years. More recently, Frank is turning some focus towards image processing and classification tools using open source software. Welcome.
Thanks. Sorry to make you read all of that. Jeez, it's kind of long. All right, let me find my presentation here. Alrighty, thanks everybody for attending. Today's presentation is on extracting Landcover and single class features from our North Carolina NAIP imagery. Here's the abstract that was in the program, and I kind of broke those out to bullet points. So as probably a lot of you are familiar with, NAIP is kind of a readily available data set. It's easy to obtain. A lot of private sector businesses and state agencies can get quick access to it. It is 4-band, so it allows us to do a lot of land cover classification, extract single features, and it lends itself to forestry applications, vegetative-related classification, and another thing, kind of surprisingly, it also lends itself to extracting water bodies from the image. So kind of the purpose of the presentation is kind of expose the value of NAIP, since North Carolina, I think every 2 years, kind of recollects the entire state, so it's a very valuable data set, more so than just being a base image data layer. You can actually derive a lot of nice usable data from it. So look at a few applications. Hopefully you'll all learn something new. I know I've already learned a lot in this session. And the idea here is just to get more out of our NAIP imagery that we have available to us. Quick overview, NAIP stands for National Agricultural Imagery Program. It's administered by the U.S. Department of Agriculture. You can go to the North Carolina State University Library website, and it's a great resource to see the data that's available for the state of North Carolina and read a lot of the particulars about the data set. North Carolina Department of Agriculture and Consumer Services, contact Mr. Dan Madding, who's here in the audience, if you have questions about getting access to NAIP imagery. And the federal resources, the Natural Resources Conservation Service Geospatial Data Gateway. So that's another place where you can get access to NAIP. Kind of jumping more into the technical side of things, NAIP is acquired during the summertime or when the leaves are on the tree. So it is during, like opposite of leaf off, it is called leaf on data. That's 1 meter spatial resolution. There are mechanisms, I think the current NAIP contract, they're actually flying the imagery that it can be processed to the 1 foot level, but the USDA contract requires the 1 meter. So there are ways to get the same data at 1 foot resolution from some private sector vendors, and it is 4-band data. And the 4 bands are the near infrared, visible red, visible green, visible blue. It is, the little highlight box up there is kind of the area that we're looking at. So everything that we can see with our eyeballs and right outside in the near infrared is kind of the region of the electromagnetic spectrum that NAIP imagery is acquiring. Now, kind of the funny thing about NAIP, that if you're going to do any work with it, and maybe you've done some work with some satellite imagery, you got to be mindful that the visible red band is actually band 1. Visible green band is band 2, and the visible blue is band 3. If you're used to working with satellite imagery, band 1 and 3 are flip-flopped. So if you just pull down a NAIP scene and do a quick NDVI, make sure that you have the correct band selected. And then we have our near infrared out in the near infrared. It's very useful for classification. Again, it could be more than just a base layer. So the types of classes that you can extract at a general level are tree canopy. You can pull out deciduous and conifer tree types. You can find water bodies pretty easily. You can, find developed areas, impervious surfaces, roads, buildings, and so forth. And then open space, grasses, fields, anything that doesn't have tree canopy or impervious on it. Some of the challenges of NAIP, if you are jumping into classification, you will find a few challenges. So you can't really just throw it in and run with it. You have to be kind of mindful of the implications of doing classifications. Shadows, since the leaves are on the trees and you have those big, fat, deciduous leaves casting shadows, you get a lot of shadowing, especially along tree stands. There is a lot of potential for confusion between healthy grass, healthy green grass, and then green tree canopy. And when you're doing image classification, you can find confusing pixels between those two classes. Bare ground and impervious, bare ground and concrete are very spectrally similar. And then sun glint. If you're working on the coast, there's waves, or every once in a while you see a lake or something, you see a lot of sun glint. So those are things that you may often find in NAIP imagery. And then since it is leaf on, and if you're looking for residential structures, you may have some problems because a lot of the houses are underneath the tree canopy. So you can apply, most of the standard methods of pixel classification: unsupervised, supervised, indices, image segmentation. Nate did a great job at covering the image segmentation. But unsupervised is basically, I like to think about it in layman terms. You throw the imagery at the software, you set some parameters, and it'll cluster the data. And there's a couple algorithms that you have options to do. And it's unsupervised is good for kind of exploring the potential of the data to be classified, kind of see where and how things will come out. Supervised, you're just collecting training polygons and you're training the data to be classified based on the classes that you're interested in. And then indices is neat in that it's a single grayscale image that you can apply thresholding to, and you can extract high areas of vegetation, or you can extract water bodies, and then the image segmentation, which is kind of the breaking the image up into segments. Now, this is an example of taking NAIP imagery. This is an area, I think Mooresville, North Carolina. And what we've done is we just applied a spectral anglemapper, and you get a pretty good breakout. And I didn't do any real editing on this. This came out pretty quickly, and I just kind of created these examples using one tile of NAIP. And this took not a whole lot of time at all. I actually used QGIS there's an extension or a plugin called SemiAutomated classification plugin. It's very useful for image classification. It works really well. The Spectral Anglemapper is a really neat algorithm that is included with the kind of the supervised classification workflow. Let's see. So there you can see there's the blue represents water, green trees, the red is impervious surfaces, orange kind of is bare ground or areas that have been excavated, or maybe there's no grass and so forth. Open is kind of everything that's not vegetation or impervious surfaces. So that can be mainly grass, kind of herbaceous fields, and then there are shadows. A lot of shadows along the road corridors and such. Now, with NAIP imagery, you can also do indices, and I think everybody's probably pretty familiar with NDVI, the Normalized Difference Vegetation Index. We're just taking the near infrared minus the red divided by the near infrared plus the red, and we can get a grayscale image that represents vegetation health or vegetation vigor. Another indices that's quite useful is Normalized Snow Ice Index. Now, the Normalized Snow Ice Index was designed for satellite imagery in polar regions. However, when you apply it to NAIP imagery, it's very interesting that water bodies come out very strongly. And I have a few examples to that. And then there are so many other ratios and band algebra algorithms. If you just have something of interest, just do a Google search, find the literature. Neat little, not really indices, but some ratioing of excess green. You can take data and create kind of like a bimodal distribution of the data, push all the green pixels to one side of the histogram and everything else is on the other side. That's just one of many examples. Here's an example of, this is Asheville, North Carolina. This NAIP image, the 4-band NAIP is on the left. And then you can see on the right that we have a grayscale image. And let's see if I can. I don't have my laser pointer with me. But, all right, so my pointer doesn't come through over there. But we can see on the right, you can see the French Broad River coming through the middle of Asheville. Kind of in the center of the image is the downtown built-up area of Asheville. So basically, the darker values are built-up areas or water. The vegetation areas are in the brighter white colors, and just represent healthy vegetation. And once you create an indices, you can start to do the thresholding. So this is an area in Asheville, and the French Broad River's there in the scene. And by thresholding, I can make the vegetation green pixels, and then I can also make the water blue pixels, something very intuitive. But those pixels actually have real values tied to them, so you can extract those as a vector format or any other raster or vector, and you can add it to your GIS and get a sense of the extent of tree canopy in your area. But also it brings out the water very nice. And the water just comes out in the low end of the NDVI. And here's another neat example. This is north of the Raleigh-Durham Airport. So what we've done here is NDVI change detection. So we calculate NDVI on the before image, NDVI on the after image, and then we set a threshold of where, where the change is. So in this case, 0.2, everything above a 0.2 difference gets highlighted in yellow. So all the yellow pixels that you see on the far right were once very healthy, tree canopy and vegetation. So this is a neat way to use your NAIP imagery to do change detection using just the NDVI indices. It's really just a difference. It's not too complicated. And I just have a few reference points. I don't know if you can see those, but. And then from here we can calculate, the total area of change or the total area of tree canopy loss or removal. This is another example of NAIP being applied to agriculture. I mean, NAIP is an agricultural program, maybe not ideally suited for monitoring, crop growth during the growing season. But if we simply take our color infrared part of our NAIP imagery over, and subset it against a farmer's field, and then calculate an NDVI, we can take that same NDVI and do a multi-class NDVI. So instead of just having just our grayscale or one color code, we've actually broken the vegetation pixels into different thresholds. Now this gets very relevant to drone technology. So if you're flying your UAV or UAS over top of a farmer's field and you're acquiring a near-infrared imagery, this application is more ideal to doing agricultural farming or precision ag from a drone platform. Now here's the water example. So this is again the normalized difference snow ice indices. And I call it the water indices, but there are other water indices that require maybe a thermal band. This we can use just the near infrared, and that's our true color bands of our NAIP imagery. Here's our color infrared. And we're just taking the visible green minus the red divided by the visible green plus the near infrared, or it's band 2 minus band 4 divided by band 2 plus band 4, and we get something that looks like this. And the yellow arrows there depict where our water bodies are. It actually does a really nice job at bringing out water bodies. So there's plenty of applications you can apply this indices, but NAIP is geared towards vegetation, but you can also apply it to extracting water features. And then obviously we can vectorize those, and now we have all of our locations of our water bodies in our NAIP scene. And just on the topic of indices, there is a nice Indices Database out there. The website's there at the bottom, or you can just Google this. Now, the 4 bands of NAIP imagery, it's kind of limited to how many indices you can use. A lot of the indices on this site are mainly geared towards satellite imagery and use other wavelengths outside of the near infrared. But it's a great resource if you like indices. Now, another neat thing, in the previous classification that I showed several slides ago, typically one of the challenges with NAIP is you get some confusion between green grass and green treetops. So what you can do from the NAIP imagery is create a texture image where the water bodies on the bottom are smooth textures. If you can see, some of the grass areas are also smooth. And the tree canopy is going to be a rough texture. So this gives us a way to kind of help break up the confusion between green grass and green treetops. And once you calculate a texture image, and there are a ton of algorithms to do textures, I'm still kind of going through the process of trying to figure out which one's the most ideal or the most appropriate. But the neat thing is we can include that texture into a band stack. In this case, this is a histogram, so we're looking at the distribution of pixel values of an 8-band stack. So band 1 is our water indices, our normalized difference snow ice. Band 2 is our visible blue. Band 3 is our visible green. And then I've also included a red-green ratio. Band 5 is our visible red. Band 6 our near-infrared. Band 7 is our NDVI. And the 8th band is our texture. So this is just a band stack that I put together in an attempt to improve some of the classification results and eliminate the potential confusion. And I like to look at the histogram because I don't have a pointer on me, but actually I do. Hey, look at that. So the blue is actually the distribution of pixel values from the water indices. This kind of olive tan is the distribution of values from the NDVI. The red is the near infrared, and then you can see kind of the visible bands are kind of all stuck here in the middle. The true color bands are really not that spectrally discriminate. They're just hard to classify sometimes. But when you kind of calculate the indices, stack it back in with the original bands, you begin to have something a little bit more powerful because now I feel like I'm moving the pixels around so I can actually isolate them. And then when you put that same band stack and you start to pick points in your image, so I've picked a water point, a deciduous point, and a grass point, you can start to see the spectral profiles of each one. So band 1, oops, okay, there it is. Yeah, so band 1 is band 2. The up and down axis are my bands, and then the profile is plotted against the different bands. So I click a point in my water, it creates the blue profile. And band 1, it's really high because I'm using the water indices. Band 2, which is my visible blue, is low. And then if we follow it and go all the way up in the texture, it's really high. So I have 2 more data sets that I've derived from NAIP that aren't in NAIP initially to do my classification. And some of the confusion, if we look at the deciduous grass and the conifer, the lighter green, the darker green, and the yellow, you can see that they kind of run together, and in this near-infrared band, they're all kind of clustered around. So it's hard to use near-infrared to break up those classes. And even in the NDVI, it's still a little difficult, but when I bring in texture, notice what happens to the deciduous curve. It drops low. The conifer profile, it drops low. But the grass jumps up really high. So by using texture, we can start to break apart green grass from green trees, which is one of the challenges in NAIP imagery. So this is another neat way, is to take your original 4 bands of imagery, do some neat indices, stack them all back in together, and create a nice layer stack, and it all comes from the NAIP. And just reference images on the left there. I have the true color on the right, so near infrared. And then we have you can make all kinds of nice looking stuff, but These are just, what I'm doing here is I'm taking each one of those bands from my 8-band stack and putting them in either the red, green, or blue color gun. So I'll just jump over here. This is the one that includes texture. And, you know, if we look at this grassy field here, I mean, it's yellow and there's probably, you know, some orange, but it's hard to tell the difference. Over here we're looking at, I think, the near infrared, and you really can't tell a difference between that grass and those tree tops. But over here, when you bring in texture, all of a sudden my grass is blue and my trees are green. So it gives us a mechanism to remove some of that potential confusion. I like creating these nice water veg texture stacks. And it's kind of new. This is what I do in my spare time. And then when you apply that to an actual classification, so this is a classification of only forest canopy using just the 4 bands NAIP. So if I just do a back and forth, you can see if you follow this power line corridor, there's a lot of tree canopy pixels that get classified, but it's actually like grass, or maybe, you know, in some of the cases it's shrub. But if we go up and look at that field up there, that's a nice grassy field. It's all tree canopy. So bringing in that texture, that grassy field is now grass, and the tree canopy is tree canopy. So again, the texture is derived from the NAIP. It's not using another data set, and so forth. And, you know, just on the theme of fusing data together, we can bring in true color orthos and do our impervious surface extraction. This is a thing I used to do for customers called man and canopy. I thought I had a nice catchy term. But I've used true color imagery to extract the impervious surfaces, and then I use NAIP to extract the tree canopy. And you know, compared to a wall-to-wall classification where every pixel has to be one or the other, we're actually representing the real true case is that the tree canopy is over top of the road, the tree canopy is over top of the house. So now we have kind of I don't know if you can see some of the tree canopy, but if you have tree canopy over top of your house, it's going to show up over top of your house. So it's not impervious surface or not impervious surface. It can be impervious surface and tree canopy at the same time. And we've, you know, overlaid some nice parcel data, so that really gives us a nice picture of the distribution of tree canopy and impervious surface on a per parcel basis. And I just thought I'd throw this slide in here. I've been to the Texas GIS Conference for the last 4 or 5 years, and they have a really nice NAIP data set, and they've invited me to speak and show applications of doing change detection with their NAIP imagery. And this is an area in the Cambrian Basin where they do a lot of oil gas exploration, and these are called caliche roads, and each one of these are drilling pads. And this point here is that pad there, and you can see within, this is the image on the left is actually 2009, image on the right is 2010, and all of these new platforms show up pretty quickly by just using the NAIP imagery and doing the change detection. All right, so kind of to summarize here, all the cool things you can do with NAIP. You know, land cover classification is a pretty typical application of NAIP imagery. Tree canopy cover, water delineation, the indices. I mean, I like indices. A lot of cool things you can do with them, especially when you combine them back in with your original data. Vegetation health, agriculture, change detection, and texture analysis is something neat as well. So that's what I have, and if you guys have any questions, I'd be happy to answer any questions. Yes, Drew.
Really interesting, thank you. Shadows, any tips for dealing with shadows, like classifying the land cover within the shadow with only NAIP?
Yeah. Question, how do you treat shadows after the classification? With only NAIP, it kind of limits you. If you could potentially use another data set, maybe an earlier flight, and apply, you know, NAIP and just see. Because sometimes when you compare NAIP, when you do the change detection, I kind of forgot to mention, since you have the trees, it weighs back and forth, there is a lot of false positives. So the minimum mapping unit that you have to pick during change detection has to be pretty big. But so using another data set for NAIP, maybe flown at an earlier time, might be one approach. The other approach is using GIS data. take your tree stand polygon and do like an intersection or a proximity analysis and say, okay, my edge of my poly line of my tree canopy actually intersects with my shadow polygon. It has to be ground or something like that, or potentially road. I've done GIS proximity analysis on just using GIS data to classify some of those shadows. For the most part, I think a lot of the shadows can be classified as a ground feature because it is a shadow, but anyway. Yep. Any other questions? I think we're... All right, thanks.